So stereospecific reactions. Electrocyclic reactions are stereospecific because a specific isomer gives the specific product. So the electrocyclic reactions gives a particular stereoisomer depending on whether the reaction is carried out thermally or photochemically. So for example, this 2,4-hexatiene undergoes electrocyclic reaction, electrocyclic ring closure reaction to give a 3,4-dimethyl cyclobutane. It gives 3,4-dimethyl cyclobutane. So let us write down the structure. It gives a cyclobutane means it is a 4-member rings, right? So this double bond should be here, and this methyl group should be here. This methyl group should be here. So it is 2,4. So numbering should be start from 3,4. Numbering should be start from here. That is 1, 2, 3, and 4. So it is 3,4 dimethyl cyclobutane. Dimethyl cyclobutane. Okay. So when this 2,4 hexadiene is heated or is considered thermally or photochemically, it gives this type of products. But the geometry we didn't see here. We have to see the geometry of these molecules. For that purpose, we have to consider it is thermally and photochemically individually. So let us see this reaction with thermally and photochemically. So this is CS3 and this is CS3. Okay, initially we are going to consider it is either thermally. So the product of this reaction is, before we are going to consider thermally and photochemically, one thing we should remember that when we are going to consider a 4n system or 4n plus 2 pi electron system. So this chart is very important while considering the reactions. So this delta is nothing but the thermal reaction. This H mu is nothing but the photochemical reaction. So this chart is very important. 4n system means 4 pi electron system. So this is 1 pi bond corresponds to the 2 electron. So this is 2 pi electron plus 2 pi electron. It becomes a 4 pi electron system. So the particular system belongs to the 4 pi electron system. When the 4 pi electron system is there, the con is there, and while at the same time the heat thermal reaction should show this. If you consider 4n plus 2 pi system, and if you consider this 4n plus 2 pi system, then the thermal reaction will be this, and the photochemical reaction will be the con. Photochemical reaction will be the con. You should remember these things for the 4n this, okay, and for 4n plus 2 it is thermally become this and photochemically become a con. So let us understand what is con and this. What is con and this one by one. On the same example, we are going to consider the con and this. What is the con and this? If you consider the con, con means either clockwise rotation or anti-clockwise rotation. Clockwise rotation or anti-clockwise rotation. It should be the rotation on the same side. Either you can rotate it on the left hand side or either on the right hand side. Rotation should be on the same side. Rotation on same side. Either left or right hand side. Okay. So let us again consider. So if you look at these methyl groups are okay. If you look at these methyl groups are pointing outside the ring, outside the system. So this methyl group goes in this direction and this methyl goes in this direction. Now if we consider the con rotation for this type of reaction, that means this methyl group should rotate in this direction. This is the clock. If we are going to consider clockwise, so it should be rotate like this, because this direction is clockwise direction. If we rotate this methyl group this direction, so it will also rotate this direction. If you consider the thumbs of both hand, one should be on the left hand side, one should be on the right hand side. Okay, now let us move these thumbs in a clockwise direction, in a clockwise direction. So if you move this in clockwise direction, so you can point out the one thumb goes down and one thumb goes up, so that it creates a trans geometry. Let us think. You can assume that both the thumbs up, right? Sorry, both the thumbs are on the, one thumb is on the right hand side and one thumb is on the left hand side. So if you move these thumbs in a clockwise or anti-clockwise direction, either direction, no problem. So let us move this on a clockwise direction. So you can point out that one thumb goes down and one thumb is up. It means these two methyl groups having trans geometry. So this type of rotation, either clockwise or anti-clockwise rotation, is always known as cone. Always known as cone. So what happening here? So when this particular bond migrates here and this bond goes here, right? So the four member ring will be formed. So see, this bond, this particular second number carbon is going to join with the fifth number carbon. So cyclic member ring is formed. So here it is, I am going to write down a four member cyclic ring is going to be formed, right? So the numbering should be there. This is 2, 3, 4 and 5, because one number is there, 1, 2, 3, 4, 5 and 6. Okay, so the in between 5 and 2 the bond is formed. So the 4 5 bond is migrated to 3 4 bond, which is at the 3 4 position, right? And now the position, we have to decide the position of methyl groups at 2 position or 5 position. So one may be at the top, one methyl group should be at the top, that is CH3 at the top, and one methyl group should be at the bottom. You can represent also by dotted lines the bottom, and the top one is by thick line. So this is a trans, that is a trans isomer. This is a trans isomer. Now once again I want to say that when we are going to consider the foreign system, and if his reaction is go thermally, then that is the considerable reaction. This reaction is not favorable. The thermal reaction is, whenever is cone is there, that cone represent the reaction is favorable, and this is represent the reaction is not favorable. Again I am going to say that whenever cone is there, whenever cone is there, the reaction is favorable, and the this is there, reaction is not favorable. Is not considered as much that the cone is there. Okay, so this is related with the cone. Now let us consider the this, how the this configuration is there. So again I am going to consider the same example. This is methyl group, this is methyl group. Okay, so let us understand what is this. Again, as I said that in case of in case of cone rotation, both the methyl groups, both the substituent rotate either clockwise or anti-clockwise direction, or on the right hand side or left hand side simultaneously. Both are moves, right? So in the case of this, means the rotation of methyl group. So okay, now let us consider this methyl groups. Okay, these methyl groups. The rotation of methyl group should be, one methyl group goes on left hand side and another goes on right hand side. So the rotation is counterclockwise, means counterclockwise rotation is there. clockwise rotation is there. So means if you consider again, now look at these two methyl groups, where we have to always consider the position of methyl groups. So these methyl groups pointed outside, these methyl groups already pointed outside, they are not in the ring. Okay, they are not like that. Again I am going to write down another structure here. They are not like that because the structure have different forms. So now these two methyl groups pointed in, they are pointed in, while these two methyl groups are already pointed outside. Okay, let us understand the difference between these two structures. Methyl groups in the first structure are outside, while the methyl groups in the second structure are inner side. So these are already outsides. Let us consider both outsides. Now let us consider your hand with the thumb. The thumb should be of right hand, should be on the right hand side, and the left hand should be on the left hand side. Look, let us consider. So if you move this, the left hand side thumb will be clockwise direction, and then simultaneously you have to consider the another thumb in the counterclockwise direction, means exactly opposite direction. If you move on the left hand side, then the second should be on the right hand side. These two methyl groups you can see here, one group goes this direction and another group goes this direction, right hand side. So both the movement are on opposite side, while in the case of con direction both the moves on the same side, or the left or the right. But in case of this rotation, the moves are always opposite side. Again I am going to write down here, moves are always opposite side. If one group moves this direction, so the another group should be move this direction. So these are the opposite moves. Again, if you consider for this example, now we are going to consider the moves. If this methyl group moves this direction, then this will also move this direction. So see the difference between this. This is outside and this is also outside. Both are opposite direction. They are not like that. They are not like that. So this kind of movement is not allowed in case of this rotation. This is the con rotation type of movement. This is a con type of rotation. So we are not considered here. We are not considered. This rotation should be either this way, or this can be like that. So you can see this. We can see this goes in the left hand side, this goes in the right hand side. Now in the second case, this particular group goes in the right hand side, or this goes in the left hand side. So both the rotation are on the opposite side. Now let us consider the product for this reaction. Let us consider the product for this reaction. Again, numbering should be there, 1 2 3 4 5 6. Okay, so again it forms four member ring system. It forms a four-member ring system like that. Okay, so the numbering should be there. Sorry, methyl group is no. We can write down the methyl group. So 2, 3, 4, and this 5. Now the position of methyl group is there. So if you look at this group goes this side, and this goes down. So both the group are goes down either or ups. If you move this way, so the both the group goes in the same opposite direction. So on this is upside also, and this is also upside. So methyl group is here, methyl group is here. So structure I am going to write down in a simple manner. Okay, now the methyl group is here. Here also methyl group is there. The double bond is here. So the methyls are CS3, CS3. So the position of methyl group, you can see the position of methyl group are on the top. So it is a cis form of cyclobutane. So in this way, the these and con structures are there. So the students should practice. I'm giving the few examples. Students should practice at home and then submit the assignments. Okay. Now the assignment form. So in both ways, thermally and photochemical. So I'm going to hint these are the 4N system, right? Similarly, another structure is write down the product thermally and write down the product photochemical also. Okay. So these are for homework. Question mark, question mark, question mark. So this is the assignment. Assignment. Students should submit on the Google Classroom. Assignment should be submit on Google Classroom. Write down structure on your plain paper and then take a photograph and upload on the Google Classroom. Okay.